We can manipulate those three special series, the e to the x, the sine of x, and the cosine of x, using these manipulation techniques. So we can substitute, we can multiply, divide, we can add and subtract, and we can also differentiate and integrate. So let me show you an example of that. The first one asked me to find a Maclaurin series. So again, I know that the center is 0. For the series f of x equals sine of x squared. And now it asks for the first 4 non-zero terms and the general term. So this is no longer about degree, right? It's just asking for 4 terms. So what this is, instead of me having to build this from scratch, where I go, okay, what is f? What is f prime? What is f double prime? And I'm trying to build a Maclaurin series, I can use and manipulate the sine of x expansion. So what we're going to do is we're going to use sine of x expansion, and the manipulation is that we're substituting x squared in where x was, right? And substitute x squared for x. So let's start with remembering what the sine of x Maclaurin series was. So sine of x was odd. So it started with x, and then it alternates in sign. So it's x cubed over 3 factorial, and then x to the 5th over 5 factorial, minus x to the 7th over 7 factorial. I'm going to go ahead and put the general term there as well. Remember, it asked for the first 4 non-zero terms. That's why I'm kind of starting this original sine of x with these first 4 terms. And then the general term was negative 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. So that is the series that I'm going to manipulate, and all I have to do is substitute an x squared everywhere I see an x. So now, sine of x squared, I'm going to take an x squared and I'm going to plug it in, right? So if I plug that in, I just get x squared. Now I'm going to plug in an x squared here, so it's x squared cubed. Well, that becomes x to the 6th, but the factorial doesn't change, so it's still over 3 factorial. And then x squared to the 5th means it's plus x to the 10th, still over 5 factorial. And now x to the 14th over 7 factorial. Now, to get the general term, don't make it harder than it is. You do not have to look at this and try to manipulate it and figure out what the heck this is. All you have to do is take an x squared and plug it in where x is right here in the general term. So remember, if you had x squared raised to the 2n plus 1, your Algebra 2 skills tell you that you're supposed to multiply these powers together. So this is now x to the 4n plus 2. That's my new power. So this is going to be negative 1 to the n because it's still alternating in sign. X to the 4n plus 2 over 2n plus 1 factorial. So that is the manipulation, if you will, of sine of x, so that I found the Maclaurin series of sine of x squared. So that is the first 4 non-zero terms and the general term. Now B asked me to use the answer in part A to find the Maclaurin series for f prime. Now pay attention to that phrase, this use your answer in part A. You have the capacity to find f prime of x. So I know that f prime of x is 2x cosine of x squared because I know how to use the chain rule. I have that. But then to find the Maclaurin series for this would be then, okay, so now I'm treating that as my original function. I'd have to find this derivative. Then I would have to find the derivative of that. Then I would have to find the derivative of that. Yuck. No one wants to do that, right? So this is telling me to use my answer in part A because to find the Maclaurin series for f prime means all I have to do is take the derivative of each of these terms. So I'm going to set this up. Actually, I'm going to rewrite this. I'm going to do f prime of x is equal to 2x cosine of x squared, which is equal to, and now just take the derivative, right? So 2x. Take the derivative of that term. Take the derivative of x to the 6. Remember that 3 factorial is just a coefficient. It's 1 over 3 factorial. So I'm going to do minus 6x to the 5th over 3 factorial plus 10x to the 9th over 5 factorial. I am choosing intentionally not to reduce this. I know that this reduces, but remember, reducing is not required on the AP exam unless it's some sort of multiple choice. So I'm going to wait to reduce, and I might not reduce at all. We'll see. 13th over 7 factorial. And then, again, I'm taking the derivative of the general term. So drop this term down and subtract 1 from it. So negative 1 to the n takes care of the alternating part. Then you're going to have 4n plus 2. You're going to have x to the 4n plus 1 because you're subtracting 1. And then you're going to have the 2n plus 1 factorial. On the bottom, I'm going to indicate that that keeps going. So these are your first 4 non-zero terms and your general term. Yes, there is some reducing that could happen. Absolutely. But I don't need to do that, so I'm not going to. I'm going to leave it just like that. So this right here is just the derivative of that Maclaurin series that I found in part A.